So today we're going to start our lesson on statistics. We're starting our lesson on statistics. And my daughter fixed our little pen so we can actually use our pen. Leslie, will you shut that light for me? If you guys are not taking your test, close your Chromebook. Close not you. You're supposed to be working. Leslie, close it. Gerardo, close your Chromebook. Brian, ladies in the back, thank you so much. Okay. All right. So today we're talking about graphically representing data. Graphically representing data. So quantitative data on a single variable is often collected in order to understand how a characteristic of groups differ amongst the group members between the groups. So typically when we think about, this is just like a sample that you would get maybe from a survey, ask questions of your classmates or something like this, okay? So typically we do a survey to get this single variable data. Charlie's Food Factory currently employs 28 workers whose ages are shown below on the dot plot. So that's that first thing that I talked to you about today, right? As one of our warm-up questions. This is a picture of a dot plot, okay? So let's look at the dot plot and answer the following questions. So question A says, how many of the workers at Charlie's Food Factory are 18 years old? How are we going to determine that? Where is number 18? Yeah, these are counting by one. So 16, 17. So this right here represents 18-year-olds. So how many 18-year-olds are there? 4. There are 4 dots. So that means there are 4 18-year-olds. What is the range of the ages of workers? Well, I don't even know what the range, I don't know what range means. Who can help me out with that? Who can? So we're going to take the largest minus the smallest. And sometimes we call that the maximum minus the minimum. Okay, so our largest number you said was what, Eleni? 42 minus, so what is 42 minus 16? God bless you. So the range is 26. So remembering that it's the smallest minus the largest, okay? So would you consider the distribution of employees to be symmetrical? So symmetrical is, remember, like something that you can fold in half and it gets you the same image on both sides. Is that symmetrical? No, it is not. Why not? What's happening? We had to say no because why? Where are most of the data points? So most of the data is on the left side. And you said between 16 and 20. And then the data, I'm going to use a vocabulary word, skews to the right. It skews to the right. So that word skews, that just means that it stretches. It stretches to the right. So it's just got a couple, think about like taking a piece of gum or something or a piece of taffy and you just stretch it. So it skews to the right. That just means that we stretch it. So there's not a whole lot of points on the right-hand side, okay? It says that the mean, which is the average, so I'm going to put a box around those because the mean, that's a vocabulary term. The mean, or the average age for the workers, is 22 years old. Let's look at our data really fast. Here's 22 right here. So when I think about the average, it says that the average age of our workers is 22. Does that make sense? Does our data represent that? Like, does that dot plot represent that? What does it represent? You think that the average is what? 21, you guess, Jerry? Yeah, 20, 21. I would say, here's what I said. I said it doesn't. It's not a good representation. So I put not, and then I said because most of the workers are less than 22 years old. Most of the workers are less than 22 years old. There are actually only 7 employees that are 22 years old or above. Most of the workers are less than 22. Most of the workers are less than 22 years old. Okay. So, what do you think made that average? Like, why is the average the way it is? What's causing that? That's how we find our average. We add up all the numbers and we divide them up. You with me? Add up all the numbers and we divide them by the total number of digits. But why do you think that it gave us when we add them all up? What caused our average to be 22? Can? Well, it's these numbers out here that are creating our average to be weird. What are these numbers called? Good job. These are outliers. These are outliers. That doesn't look very nice. Let's try that again. So outliers are just data points that lie outside of the normal distribution. Awesome. Awesome. So outliers affect your mean. They affect your mean. They actually, if they're outlying on the right, they make your mean, they like estimate, give you a higher estimation. So probably if they were below the data set, they would give you a lower estimation. So we're going to create a dot plot in this second example. A farm is studying the weight of baby chicks. After 1 week of growth, they find the weight in ounces of 20 chicks, and the weights are shown below. So all we're doing is constructing a dot plot. So we're just going to take each number. So 1 chick weighs 2 ounces, and I'm going to put a dot there. 1 chick weighs 1 ounce. I'm going to put a dot. 1 baby chick weighs 3 ounces. I'm going to put a dot. Do you guys see what I'm doing here? Yes, you can fill that out without me talking each point. Okay. So when you finish your dot plot, when you finish up your dot plot, hopefully you get something that looks similar to what I have. Hopefully you get something that looks similar to what I have up there. Okay, do we need more time to fill that out? Everybody good on the dot plot? Okay, let's move on to example number 3. So for example number 3, the following histogram shows the ages of workers at Charlie's Food Factory. Similar to exercise 1, but it's in a different representation. Exercise 1 gave us a dot plot, and now we're looking at a histogram. So how many of the workers are have the ages of between 19 and 21? How many workers fall in that age range? Yeah, 11. What is the disadvantage of a histogram compared to a dot plot? Well, can you tell me how many how many of the employees were 19? Yeah, so it gives you a range. So the disadvantage is that you get a range of data versus points for each. So we just get a range. Does a histogram have any advantages over a dot plot? Well, did we have to count 11 dots, or was it really easy for us to look at the histogram and figure out how many employees fell in between that range? So the advantage of a histogram is just that you are not counting multiple dots. So if you have 3 or 4 dots to count, that's not a big deal. But if you have 57 dots to count, probably you should use a histogram, right? Does that make sense? Okay. Questions on, so I want to talk about a histogram really fast compared to a bar graph. Do you guys notice something about the histogram compared to a bar graph? Do you guys remember what a bar graph looks like? A bar graph is just like a histogram, except there's spaces in between the bars. And this one doesn't have any space because we don't put any gaps in the ranges. There are no gaps in the ranges. Okay. All right. Exercise number 4. The 2006-2007 Arlington High School varsity boys basketball team had an excellent season, compiling a record of 15-5, 15 wins and 5 losses. The total points scored by the team for each of the 20 games are listed below in the order in which the games were played. Complete the frequency table. So we're going to take each one of these numbers and we're going to fit them into the frequency by making a tally. And then we're going to make our own histogram. Okay. So we had a score of 76. So I'm going to put a tally on the 70 to 79 range. Do you guys see that? We had a score of 55. So I'm going to put a tally. We had a score of 76, tally, score of 64, score of 46, score of 91, score of 65, score of 46, score of 45, score of 53, score of 56, score of 53, score of 57. So now I have 5 tally marks. So I cross it over. Score of 67, score of 58, score of 64, score of 67, score of 52, score of 58, and a score of 62. So I've made my tally marks. I'm going to wait a second for you guys to do that. I'm going to wait for you to catch up. Braden, do you not have your journal at all? You should have your journal. Can you look in your bag? So once we give ourselves tally marks, what do we do to find the frequency? What are we doing there? Just adding up the tallies. We're just adding up the tallies. So that's what I want you to do. Add up the tallies. So do you want to try any of this?
I don't know if the humor even started.
Okay, well.
I want to do good, and she's like, don't even know.
Okay, well, substitution. You are substituting in an expression for another variable. So you're replacing x with 3y plus 4, and you're solving. So let's talk about it. How many? So I had a frequency of 3 in the range of 40 to 49, a frequency of 8, 6, 2, 0, and 1. So I'm going to label my axes number of points. So this is the amount of points. And then I'm going to label it on the Y, number of games. And then I have to label or make my ranges. So the first thing I'm going to do is just kind of block out every other grid. I'm going to block out every other grid. And I'm going to use the same range values that they gave up top. So the first range is going to be between 40 and 49. The next range is between 50 and 59. The next range is 60 to 69, 70 to 79, 80 to 89, and 90 to 99. And then I'm going to just count on the Y side. 1, 2, 3, 4. I'm going to mark 5, 6, 7, 8, 9, 10, because I didn't have anything larger than 8. So if I go up to 10, that's perfect. So for my first bar in my histogram, in the 40 to 49 range, I had a frequency of 1, 2, 3. So I'm going to just make a bar, go up 3, and I'm going to just lightly shade that in. For the 50 to 59, I had a frequency of 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to shade that in. Oops. Okay. Then for the frequency 60 to 69, I had 6 of them. So make that bar and shade that in. Count up 6. And our bins are 2 units wide. Our bins are 2 units wide. So shade that in. I don't know why that's not staying shaded in. It's really making me angry. Okay. And then 70 to 79, I had two games where I scored 70 to 79 points. I didn't have any for the 80 to 89, so I'm leaving that one, leaving that bin totally empty. And then for 90 to 99 points, I had one game. So we have just created a histogram. We have just created a histogram. Okay. We have just created a histogram. So we don't have anything in the 80 to 89 range, but in the 90 to 99. So those next 2 pages in your note packet, that's going to be part of your homework, but we're not done. We're going to talk about central tendencies. So skip to measures of central tendency. Skip to the 2 pages and go to measures of central tendencies. Measures of central tendencies. So this should really be review for you. Measures of central tendency: mean, median, mode, range, right? Those are numbers that we learned probably, I don't know, I'm guessing 3rd or 4th grade. We learned about mean, median, mode. Okay. So we've worked with the mean already. We said that the mean is the what? What is the mean? It's the average. What is the median? It is. It's exactly that. It's the middle number. Do you guys remember what the mode is? Say that again. Yeah, it's the one that appears the most. Yeah, very good. The mode is the one that appears the most. Okay. So a survey was taken amongst 12 people. That's why there are 12 numbers down there. on the number of passwords that they currently have to remember. The results in ascending order are shown below. So when you have a set of data, you want to put them in order from small to large, especially when you're trying to find the median. That's the first thing that I want you to remember. You want to order your data from smallest to largest. So when we talk about finding the median, we're looking for the middle number. So I have 12 numbers here. So the halfway point is right in between, like right after 6 on one side, 6 on the other. Do you guys see how I broke that in half? So if I have an even number of data points, I have to take the two numbers that are on either side of the middle and find their average. So when the data points, you have an even number of data points, you add the two numbers on either side of the middle. And then you divide by 2. So 2 plus 3 divided by 2 is what? It's 2.5. So that's my median. That is my median. To find the mean, because it also asks us for the mean, if I wanted to find the mean, well, that's just the average. That means I add up all the numbers, 0 plus 3 times 1, because I have 3 ones, plus 2 times 2, because I have 2 number 2s, plus 3 times 1, 2, 3, 4 3s, plus 4 plus 6, right? And I'm dividing all of that by what number? How many data points do we have, or how many people did we survey? We surveyed 12 people. Well, when I add all of those up, I got 29. So 29 divided by 12 equals 2.416. And I just put ... So this is my mean. Okay, this is my mean. So we're just going to keep using mean and median. We're just going to keep using that. So example number 2. God bless you. Mr. Okafor's algebra class was trying to determine if people speed along a certain section of roadway. So they collected the speeds of 20 vehicles, and they're displayed in the table below. So this is a frequency table. So if we want to find the mean and the median, we have to think about, like, this means that there were 2 cars traveling 33 miles per hour. So the first thing that I did is I listed out all of my data points. So we have 20 points that we're going to list out. So 29. And then I had 2 cars traveling 33. So 33, 33. I had 4 cars traveling 34. So I'm going to write the number 34 4 times. I had 5 cars traveling 35. I had 3 cars traveling 36. I had 2 cars traveling 38. 2 cars traveling 39. And I had someone running really late for work, and they were traveling 54 miles per hour. So there are 20 data points. So I know that the middle is going to be after the 10th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the middle is right here. So remember, if I have an even number of data points, I take the two numbers in the middle and I add them together and divide by 2. So basically I'm finding their average. But what is right in between 35 and 35? Yeah. So the median is 35. It's the middle number. To find the mean, I took in my calculator 29 plus 2 times 33 plus, someone needs to do this math probably, 4 times 34 plus, do you guys see where I'm multiplying 5 times 35? What am I going to do next? Plus what? Yeah, 3 times 36 plus what? 2 times 38 plus 2 times 39 plus my 54. And I'm going to take that total and divide it all by 20. So when I totaled it up, I got 722 divided by 20, and that equals 36.1 miles per hour. 36.1 miles per hour. Okay. So the speed limit along this part of the highway is 35 miles per hour. Based on your result from part A, is it fair to make the conclusion that the average driver does speed on this road? Because the average, what was our average? Yeah, that's our mean, right? So our average speed, which is our mean, was 36.1. So should we conclude that pretty much the average driver speeds on this road? Yeah? 1 mile per hour over is speeding. How many people? Okay, so valid points. But the answer is really no. And here's why. What do you see right here? One car was traveling what? Yeah, one car was traveling almost. So one car was almost, is that your dad you said? Oh, almost driving 20 miles over the speed limit. So that's probably not going to give us a very fair average, right? In fact, 12 of the 20 drivers drove at or below the 35 mile per hour speed. 12 of the 20 drove at or below. So that brings us back to that. What is this called again? This 54 is a what? Yeah, it brings us back to this whole idea of outlier. So when you're using central tendencies, this is special. Median is the better display or representation of data when you have an outlier. So when you have an outlier, you want to choose the median over the mean. Okay, you want to choose the median over the mean. Tomorrow we're going to do something different where we're going to get rid of the outliers, right? We'll just pull the outliers out so that way we get a better distribution, like a better 5-number summary and things like that, better central tendencies. Okay. Flip it over. We've got two more examples. So when we do a statistical study, it's not always possible to obtain information from every single person in the population, right? If we wanted to do a survey at school about your favorite lunch and we gave them a choice, like hamburgers, pizza, whatever, could we interview every person in the school? You think that we could interview every person in the school? How? But everybody doesn't go into the lunchroom. Yeah, so.
Well, we just email everybody.
Okay, but what about the kids who don't ever answer their emails, right? So you would get a majority, but it's very unlikely that you would get the whole population, right? So we do what's called a sample. We get a sampling of the population. We want to make sure that that sample represents everybody, right? So in our example right here, it says to determine which television programs are the most popular in a large city, a poll is conducted by selecting a sample of people at random and interviewing them. Outside of which of the following locations would the interviewer most likely find a fair sample? Explain your choice. Okay, so let's talk about each one. Why would it not be fair to be outside of a baseball stadium? Okay, so more likely to choose sports. So they may have a sport bias. Okay. What about people outside of a concert hall? Yeah, choose music. So they have a bias towards music. Yeah, so someone outside of a comedy club probably is going to have a bias towards a sitcom or some comedy show. Everyone has to go get food at some point, but what if they stood outside the Publix? Yeah. So like it depends on what type of grocery store they stand outside of, right? Very good. So every single one of these has some type of bias. So this is going to have a bias toward the type of grocery. Does that make sense? It'll be a bias towards the type of grocery. So we're going to finish them today. And once you finish this part 1, you guys have a part 2, which is using your computer. So are you ready for part 2?
No, can you do
Nope. Okay. So neither one of those, none of the 4 give us a totally unbiased sampling. So we just wanted to talk about bias. So Truong is trying to determine the average height of the high school male student. So we want to just kind of do a sampling of find an average height of a male student in high school. So he decides that he's going to interview or take a survey of everybody on the basketball team. So he surveys the 14 players on the team, and then heights are given below. So we need to calculate the mean and the median. So if I want to calculate the median, what do I have to do first? Why? Okay, so that's going to be question B. Remember that. Let's find the median. How do I find the median? What do I need to know? Are they all in order from smallest to large? Yep, they are. So they're in order. Check. 14 players. So what's half of 14? 7. 1, 2, 3, 4, 5, 6, 7. So the middle is right here. So I need to find the average between 74 and 75. 74 plus 75 divided by 2 equals 74.5. That is my median. If I wanted to find the mean, I would take 69 plus 70 plus 2 times 72 plus 3 times 74 plus 75 plus 3 times 76 plus 2 times 77 plus 82. When I do that, what number do I get? Did I do that? Or did I just do it all at once? I think I did do that. I got I did not. I didn't add all those together. Well, when I took that number and I divided it by 14, I actually got 74.6 inches. So this is the average or the mean. So Eleni, is this data set a fair sample? You said no, because why? Yeah, but not average of every student, right? So basketball players are typically taller. All right, this last one, I'm not going to go through. I'm going to just post out the filled out notes because I want to get you guys started on your homework.